There's one last small topic related to uninformed search, and that is that we have in principle a choice to search in two different directions, at least in the case where we have just one single starting state and one goal state. Um, so basically, you can look at this maze where we have some person in field C3. So this is the maze. And the goal is now to find a path to this position where the star is. And this is an abbreviation, so these paths are always the one that are extended up to the end of a full path. So basically here, this is one direction where our agent can walk from C3 to E1. So this is one direction. There's one path. If you go to the other path, you basically go to B4. And then you have a choice point again between going either to A4, where you have more choices, namely going to either B5, this is this one, or going down to A2, and then having the choice of either going down to A1 or going down to C1. So this is this path. And then the alternative would be to go in this direction up to this cross point, going either to E5, is this one down here, or going to D4 and then finding the goal. So in this case, you get this search tree. But obviously, we could also do it the other way around, that in the same situation, we try to find a path starting from the goal. So this is then called goal-driven search, and basically then you can choose to go from D3 to D4. So then here, then you have the choice going in one direction to E1, so E2, and this is this path here. And the other choice is that you go to this cross point. I think there's a cross point here. Sorry, I missed this one. That is the C4, where you either go to C5 and then to E5, or you go the other direction where you say, I have also the choice of going down to the B4. There I have a crossing again, and then I find the C3 very quickly. So you see that searching in different directions, you might find the goal relatively quickly in one, but less quick in another one. In this case, this doesn't make a difference. In both paths, you have the same number of branching points. So that doesn't make such a difference, but there are applications where the branching factor makes a difference. So first of all, we obviously have the question, is there a unique goal? So if you have, for example, chess, write chess, yes, this is how you write chess, then we start with one unique position, namely where the figures are all on their suggested position in the beginning, but there are probably not infinitely many, but many millions of winning positions for one of the players, winning and losing positions. So it wouldn't make any sense to start from those, because then you would have to do millions of search in parallel. So basically, you can only do this goal-directed, goal-driven search if you have a clear and unique goal. We had this in our example of the maze. So here you have one goal, and one starting point. So then you can do this exercise in both directions, but you need one goal. So the other question, and that's I think the more interesting one, is if you look at the branching factor, then basically we know that searching to find the goal somewhere here might take maximally branching factor times to the power of depth. So now the question, if we, for example, want to have a search where we look for the question whether Matti Hüntjes, that's your programming teacher, whether he's a descendant of Willem van Oranje, that was one of the kings of the Netherlands 200 years ago, I don't know. And we have now the possibility to start. So basically we have some person, Matti, here, and we have a Willem van Oranje. And the question is, in which direction should we search in order to check whether there is a direct path somewhere between Willem Oranje and Matti Hüntjes? So think a bit whether you see what the answer here is. And the answer is obviously in what I wrote up here, we want to keep, of course, the distance between the two will be the same no matter which direction we search, but we want to look at the branching factor. So what is the branching factor if we do data-driven, so from Matti Hüntius? Then what does it mean? It means if we look for a successor, so someone who lived before, one of his ancestors, then we have to check for his parents. So this would be the mother, this would be the father, and then we look at the mother and so forth. So basically we have a branching factor if we do data-driven of 2. And historically it has been shown that someone like Willem von Oranje had on average 3, over the generations they had 3 surviving children. So here we have a branching factor of 3. So basically what you have to check if you want to do this check in one direction of the grandchildren, here in this example I did the check starting from Willem von Oranje. If you check for the grandchildren and the grandchildren, then you have a branching factor of 3. So we get a 3 to the power of n search space. And if we look at the parents of Matti Hüntius, then we got a search space, as I said, of 2 to the power of n. And this makes a huge difference because we have about 10 generations between Willem von Oranje and Matti Hüntius. And then basically we have to search through about 60,000 people if we do start from Willem von Oranje. And we have about 1,000 if we start from Matti Hüntius, so that gives us 2 orders of magnitude difference. And I've been struggling here a little bit about the choice of what is data-driven and what is goal-driven, and that obviously depends on the formulation of the problem, so that's why I was struggling here a little bit. So if you want to check whether your starting position is Willem von Oranje, and whether he has a descendant, that would be Matti Hüntius, then the search direction would go from the initial position, and that would be Willem von Oranje, to the goal Matti Hüntius. And this is how this is written down. So this is data driven when we start from Willem von Oranje, and it would be goal driven if we would start from Matti Hüntius. But you could always, of course, formulate the question differently, and that it would also be different naming, whether it's goal or data driven. What is important is that you understand, depending on the search direction, what the branching factor would be, and that is simply from Willem von Oranje it's 3, and from Matti Hüntius it's 2. So that makes a difference.